Among these nondescript buildings, these are the only clue there is something special here. And very special it is. It's a new high-tech defence facility, looking like something out of a sci-fi movie. It's the only one of its kind in the world, and we've been granted permission to go in. Well, it's a very pleasant 20 degrees out here. That's almost a summer's day by Melbourne standards. But I gather from the gear they've given me, it's not going to be quite so nice in there. Let's find out. Remarkably, this chamber can simulate any environment on Earth with the touch of a button. They can dial up the hot, humid conditions of Southeast Asia or turn the temperature right down. It's very cold in here. Simulating the conditions of the highlands of Afghanistan. So it's about minus 20 degrees, humidity about 20%, dry and cold. The purpose of this weather-on-demand facility is to help test and design equipment for our troops. It has to simulate all fighting conditions. Today, chemical warfare suits are being tested. They're bulky, heavy garments, and most importantly, the fabric can stop the very molecules of a killer gas penetrating.
The suits generally have activated carbon in them, most of the military suits, and so the activated carbon sucks up all of the chemical warfare agents.
Oh, there's more. Just standing here in all this gear makes you feel quite immobile.
This is not very comfortable.
Not to mention a tad claustrophobic.
In there, is that?
Yep, that's normal.
Meanwhile, the chamber's being filled. Fortunately, only with a chemical weapons simulant.
Well, we use methyl salicylate, which is the active ingredient in the sports rubs, the thing you'd smell around the changing rooms on a Saturday afternoon.
Not only do soldiers get exposed to nasty chemical weapons, they have to work in these suits in tough physical conditions. So, a trainer puts me through my paces. I'm not doing a lot of exercise really, yet my heart's pounding and I'm gasping for air. Heart rate and body temperature are measured continually to see what level of exercise a soldier can cope with. I'm glad that's over. So here we've got my heart rate, is it right?
Yep, that's right. So what we see here is we see when you were getting dressed, so your heart rate went up a little bit while you were getting dressed, so you're probably a little bit stressed while that was happening.
It wasn't much fun putting that mask on, I can tell you.
That's right.
Heart rate goes up during exercise and down when I stop, which of course is normal. But my body temperature is a different story. So what's that showing?
So this one's showing skin temperature. So again, it's over time. So when you started getting dressed, your skin temperature started climbing.
Gee, yeah, quite steadily actually.
Yeah, and it's because you're completely encapsulated, which actually means that it's much harder for all of your sweat to escape, which is your main form of cooling, so evaporative cooling. And when that avenue's closed off to you, your core temperature tends to increase and can increase quite rapidly in some environments.
And that's the problem with these suits. If I continued exercising, my body temperature would climb dangerously high. This facility allows the military to find out how much they can work their soldiers in this gear.
So with particular temperature and humidity combinations, they're only allowed to do particular intervals of work to intervals of rest.
But of course, the key thing is, do the suits work? This mannequin is the test soldier.
He can do anything a human being can do. That's his beauty. He really is quite good at moving. He has full articulation of arms, legs, throat, neck and head.
The team transformed the mannequin into a test soldier by developing these sensors. They can pick up the tiniest of chemical leaks. Each flash indicates a measurement. The sensor technology is ingenious because it's so simple. Inside here is a tiny piece of filter paper coated in iron nitrate. Now that'll change colour when it absorbs just a few parts per billion of the chemical. And that colour change is detected by reflecting light off the filter paper. That's what the flashing's all about. And then that light change is converted to a voltage and you get an output. The computer tracks the output, a different coloured graph for each sensor. The mannequin can be put through a whole series of realistic movements. So rather than just the fabric being tested, the joins are too.
Well, like any clothing system, you have to join parts together. So wrist seals, the hood seal around the respirator on a CB jacket, We know that respirator seals around the face are very, very important, and we test for those in a number of ways.
The suit might leak a lot more when the mannequin bends over, for example, than when the mannequin walks, and that gives us a lot of information about design and how we might rectify those leaks.
Getting the best, and of course safest, outfits for our soldiers is paramount. So they're well kitted out for any job they might have to do.